DCG's development update. We are here with the platform, the core, and the mobile team to give you an update of what happened over the past 2 weeks. If you have any questions during the update to the team, to the topics, just post them in the live chat below using a Q or a question prefix, and we'll be answering those questions at the end during the Q&A, so please stick around for that. Without further ado, let's dive in. Sam,
Well,
would
yes.
you kick us off?
Thank you very, very much. So we focused on two big items, actually three big items for the last 2 weeks. The address system, so that's the main feature in version 3.0 of platform. We also are working heavily on -SPV, which is the main component left for getting the iOS wallet out. And also we are working on an improved JS SDK experience that will allow developers to have a better time than in the previous version. So so basically me, Lukasz, Ivan, and Paul worked on the address system. We've been going a little hardcore on this, and it's almost finished. We're in the last finishing touches. We've been deploying it to DevNets and testing it, and we'll get into that. I also worked quite heavily on GroveDB in the last 2 weeks, and talk about that. Paul, he's made changes to the -Evo tool to support platform addresses, as well as some fixes from issues from community members. And we're actually very lucky today because we're going to hear from Dustin Face and Borja. I always mispronounce his name. He will tell everybody how it's pronounced. We will hear from both of them. Ivan worked on the JS SDK as well as reviewing platform addresses. So let's go and start with Dustin Face because he has not had been on one of these calls yet. So it's going to be great to hear from you.
Yes, hey, it's Kevin.
Speak louder, Kevin.
Dustin Face. Oh, hey, no,
they're all the way in the United States and in Asia.
Too far away, yeah. Hi, I'm Kevin. I'm also known as Dustin Face, one of the new devs, as Sam already told. Working on Rust dashcode to get the SPV client into production. And this sprint, I worked again a lot of cleaning up a lot of dead code and refactorings in the SPV part, which still will be an ongoing task for a while, I think. Some general cleanups in the repository, and I started to rewrite the sync workflow to improve the sync process overall and making it better maintainable and testable. While I was working on this, I implemented parallelized filter matching, which speeded up the filter matching quite a lot in the new sync workflow where I match them in batches. Then I worked on quite a bit of refactoring in the wallet to make it a single network wallet, which was before like a multi-network wallet, which introduced quite a bit of complexity. And I worked on a few fixes here and there and continued to work on the CI overhaul, which I worked on the last sprint already, which is mostly done now. I just need to split it out into a few separate PRs, and then the CI will be much better, hopefully. Yeah, that's it from my side.
Thank you. Borja.
Okay.
Hi everyone. I'm Borja. I'm really new to the team. I joined 3 weeks ago, so nice to meet you all. And I'm glad to be here. I'm working as as you already hear. I'm working along with Kevin, working on Dash SPV. We are trying to clean up the code, refactor, and make everything a nice place to work in, so we can deliver good quality at the end of the day. What I was working on was mainly the storage logic. I made a huge refactor in that place, fixed some bugs in the way. I also found some new I also found some new issues that we already solved, and along with improving performance and removing unnecessary middleware, I'm helping prepare kind of the groundwork for the sync process. We want to make it um cleaner and scalable. Right now, we have some issues that are hard to address and hard to scale. So yeah, I'm working also in that so we can deliver better. And not much more. The other things I made are kind of internal improvements on how the system behaves in the inside with
Well, that's
that
great.
target in mind.
It's nice to hear from both of you. I'm gonna ask the question now because it's gonna come out very soon.
The when.
No, well, I won't ask you guys very right away. First thing I'm gonna do is I'm gonna tell people our plan for iOS, the current plan. Um, so the plan is for a Dash SPV to be pretty much usable in an iOS wallet, we still need some more work. It's not there yet. This is the component that is left, the main issue preventing release on iOS. And, it's definitely uh, not Dustin Face's or Borka's issue that it's not good because they joined and they are the people that were hired to fix the problem. So
Yeah.
thank you guys very much for fixing the problem.
You're welcome.
So the idea is until the 15th of January, they're going to make it not in a perfect state, but good enough that we can use it in iOS. At that point, iOS. So the iOS SDK is basically just waiting for this component to verify that everything is working. Once this exists, I estimate that it will take about uh, 2 weeks to 3 weeks to fix everything. And then we have about 2 weeks of, I would say, integration into the iOS wallet, some merging of the previous things. We'll basically have everything working. We just have to hook up the UI to the new SDK, and I believe that work will take about 2 weeks. So, and by that time, the new Dash SPV library with a lot more performance improvements and ready for production should be ready. These are estimates. We do our best to go with them. Like we do our best um, to do them in time, like to do the work in time. But of course, we can only say, okay, this is how long we think it's going to take when things take quite for big features like this. So I just want to ask, because I want our community to believe what we say. Does this seem like a reasonable plan to you, Borka and Dustin Face? And you can call me out and say, no, we need more time. or this seems reasonable?
No, I mean, I think it's reasonable. I think we can make it that way at least.
Yeah, I agree. Like, of course, you never can't really tell for sure. Like, there were surprises already, and 15th of January sounds a bit. Yeah, I
Well,
would
15th
push
of
it out a
January
little,
is just for
a
the
few more days maybe.
yeah, 15th
But
of January is
yeah,
for a version that can be used. I'm not saying it
yeah,
works
yeah, okay,
100% of the
okay,
cases. Like there'll be some rough edges and
yeah,
maybe like but you guys will have an extra month to fix the rough edges. So I think that
yeah,
that will be fine.
yeah. Sounds
But
good.
you know,
Yeah, the
so
storage is
so people
almost. Yeah, sorry.
yeah. No, please continue.
Yeah, as I was saying, the storage is already, I would say that done with the refactoring, and I'm ready to kind of fix small issues that can appear eventually. And the only thing we have to work on right now that I know is the sync phase. I don't think it's gonna take that much time. I mean, you can always have surprises. Is the funny part about coding. Uh, but yeah, it looks reasonable, and we can have something usable by then.
Yeah. Excellent. Thank you, guys. Okay, let's move on.
This
I
is Łukasz's slide.
Oh yeah, then I'll take it. Okay, so Lukasz was helping me on platform addresses. Some of these items are going to seem a little bit weird without explaining the other work that we did, but basically, Lukasz was very much involved on the SDK, the Rust SDK part of platform address support. So I was writing the platform code, and Lukasz was writing the SDK code. This means basically I was writing the backend blockchain code, and he was writing the SDK code. And very often the SDK code is more complicated. It depends, but very happy that he finished that, and it's now working. And we've been testing it out in a DevNet already. So all the state transitions are working right now. Um, and yeah, so very good there. Uh, he also made a fix. So currently we were not verifying the app hash in finalized block. We were actually, it was actually being verified on the next block. Why this is a problem? Well, it's not a very big problem, but we now have fixed it. And basically, the next block, the node would stall instead of the current block, the node would stall. But stalling on the next block would cause uh, you to have to resync the entire chain. So verifying on the current block, if when you get the update, things automatically work. So if there was ever any network split, um, and all the Evo nodes when could not agree on the state, then this feature is a lot is very good. Now we have so far in the last year and 3 months or so since platform's been out, we've had two such events. So I think pretty much only one, and it wasn't even yeah. There was one event like this. So where we had a chain stall. The other chain stall wasn't really because of this. And even the first one, it's debatable how much this would have helped. But there are times if we ever make a serious error in our development, or maybe it's not even an error, that there are many ways problems can arise. This will really help the network. RSDAPI, fix error messages in broadcast state transition. Yeah, this is just like error messaging. Maintenance things, like one big thing is that we upgraded to Rust 192, so that gives us features in the code, in the code we write. And yeah, it's not very important to talk about any of these. He worked on a way to replay drive ABCI state and find bugs that way. But so far, everything has been fixed, so we're doing pretty well. Okay, let's move on. JS Evo SDK. So this is work by Ivan. So he's still working on the conversion methods. I'm not going to talk much about this because in the last 2 weeks, he was off for about a week. So there's not much of an update. He did review platform addresses. He's currently working on the JS SDK queries for the platform addresses and the state transition for the platform addresses in the JS SDK, right? We wrote them in the Rust SDK, and now we just need to also write them in the JS SDK. Often this is not rewriting it; it's mostly exporting things in WASM and putting a nice, you know, beautiful bow tie on it package. Okay, let's continue. Yeah.
Oh,
Yes, I spent most of the sprint working on Dash Evo tool. Kind of like, so we're planning to do a release. I don't think it will be V1 yet, but once platform addresses come out, we're gonna do like maybe a 9.4 release, and we want it to be decent at least. I think it will
0.10.
0.10.
Yeah.
Ah,
Nothing stopping you at 0.9.
yeah.
0.
I think it's gonna have some like Dash Pay functionalities. Basically the stuff that doesn't heavily depend on SPV. Whether or not we include SPV as a testing feature type of thing, maybe like gated behind dev mode or something. I don't know. I haven't discussed it with Sam yet, but it could be done. But yeah, I mean, the version of Dash Evo tool that we've been testing, that I'm working on right now, it's I've been using it for testing SPV, testing Dash Pay and stuff. So yeah, we're getting really ready for a nice V1 that will be really we want people to use. So this sprint I've been mostly spending time like hardening the code in Dash Evo tool, fixing issues, fixing UX and stuff. Yeah, and in addition to like testing platform addresses, both in Dash Evo tool and this week we did some stuff with the TUI strategy test actually. So like we got a DevNet up and we ran a strategy test in the TUI to populate like 1 million addresses on the DevNet, and then run some tests like basically in that state with the state being populated with a ton of addresses. And so yeah, I mean, I think that's pretty much it. I didn't really add, besides the platform address stuff, I didn't add much else to DET. I also added some stuff for the DIP 18 and 17 that Sam wrote in platform and Rust Dash Core. Yeah. Yeah,
Thanks,
so
Paul.
that's all. I'll be going through the rest of the GitHub issues in the next sprint as well. And yeah. Thank you.
Yeah, thanks. So, this slide people might remember, but it's also a focus that I've been working very, very hard on the last 2 weeks on, is how do we keep address queries anonymous? So when you query the system, you don't want to know, hey, this is all my money, right? because then like your IP could be, okay, this IP has like, I don't know, this much money. You don't want that. Um, you basically want to have all your addresses pretty much anonymous to some degree of privacy. So how do we build this? Last time I kind of explained how I was going to build the system, and I had started building it, and now it's been built. Um, and this is probably a new type of sync that does not exist in blockchain right now. It uses the state tree and it uses a provable count some tree, which doesn't exist in blockchain. So that's why I think nobody else has this type of sync. And it basically decomposes the tree into subsections, verifies each subsection based off of the uh, root of the trunk of the higher trunk, and will get you your addresses while keeping anonymity. So, what does this mean in practice? Okay, let's go to the next slide. Oh, wait. Oh, maybe next slide, and then we'll go back to this one. Oh, there we go. So, I did a simulation. So we've been working around the clock to have a demo of this today. Working weekends and everything. It's not as we were setting up the DevNet, there was an issue and then another issue, and we just ran out of time. We've solved a few. Um, in GroveDB, I made simulations. In Drive, I made simulations for real usage, and I'm gonna give out those simulated data. But we're very close to proving this on the DevNet. Of course, the DevNet is still not 100% accurate because it doesn't the nodes on a DevNet are pretty centralized, whereas on mainnet they're very decentralized. So we will have probably a slightly higher latency on mainnet, but this is kind of an idea of how things will go. So because in terms of storage, um, well, it's going to be the same storage. So in this case, I did a test with 1 million elements in the tree. This means that there were 1 million addresses in the system. And I had a wallet with 500 addresses with a gap limit of 100. What does that mean? I have 500 addresses that I'm looking for, and I have a gap limit of 100. So I don't actually know when I start syncing that I have 500 addresses to look for. I am actually just looking for the first 100 addresses because I don't know how much my wallet has synced already. So just to understand that, I am making a simulation that is accurate, like shows how the system would really work in real time. So it would start by looking for those 100 addresses, and as soon as it's found one, it would always increase the gap limit. So let's say it finds an address at index 85. So then it's going to be looking, it's going to uh, look for addresses up to 185. And then let's say it finds one at 160. Then it's going to be looking up to 260. And it will always be looking 100 past the last address that it found. Yeah. The min depth per chunk and the max depth per chunk, this is basically parameters to the function. It means that the maximum amount of elements that we can get back are 2 to the power of 8 minus 1, which would be 2 to the power of 8 minus 1. I'm sick. Please excuse me for not knowing this. So it's 255, obviously. Oh my God. I should be shot for not for I'm very sick, guys. 2 to the power of 6 minus 1 is 63. So the minimum that you would get back in a chunk would be uh, 63, and the max that you would get back in a chunk when querying the system would be 255 addresses at a time. And we wrote the thing saying that we could contact 40 different Evo nodes simultaneously. So yeah. And we say that the latency to reach every Evo node, like let's say I make the request and the request comes back, is between 60 and 300 milliseconds. Okay, so how long did this whole system take to sync? Well, basically, it took 5.77 seconds for this system to find your addresses and sync it. How much time did it take if you didn't have concurrent requests? It would be 56 seconds. So the concurrency really speeds everything up. There were 414 queries to the network. And we found 500 keys, and we proved that the next 100 do not exist. So that's basically the sync system that I want for platform addresses, and it's all built, and we're just testing it now. So it will basically sync your address balances anonymously when you load up the wallet, and it will do so extremely fast. Now, when in 2 weeks' time from now, we will have it on a DevNet, and we will show this to you, and hopefully with a wallet of 500 used addresses, which is very much more than the average, right? Most people have maybe like 30 to 100, right? Used addresses if they've been using the wallet for quite some time, or not even quite some time, for a few weeks. If they're power users, obviously it depends on the user, right? But the point is that this very quick sync is going to be nice, and because of birthday paradoxes, which basically means that the more you add addresses, it doesn't actually increase not exponentially. It doesn't increase linearly the amount um, of queries that you actually do to the system. It increases them logarithmically. So it's quite cool. Okay, let's go on.
Hey Sam, I don't know if this is something that you can answer, or
Yeah, sure.
maybe this is something for later, but could you describe a little bit more, just because it's so interesting, like what are the requests and what are the concurrent requests? Maybe I missed that. Like, how are you able to, ask 40 at the same time? Like, what is the difference
Sure.
between the
Oh, that's so
requests?
good. That's such a good question. So basically, I first do one request for the trunk node. Sorry, for the trunk query. So the trunk query gets the tree, and it's a provable GroveDB query, provable platform query. So it gives you the GroveDB path to the root, and then you verify that that the root is signed based on the block. That's basically how all queries work, right? But we're interested in the Merc subtree for the trunk. So let's imagine, right? The system actually, I think, gives you back 64 elements on a tree of 1 million. It will actually automatically calculate based off of the count the ideal height to give you back. Uh, it's either going to be like 64, it could be 32, it could be 128. It's going to be one of those three, depending on actually -1, right? Because yeah, if you had a depth of 2 in a binary tree, and it's full, right? You would have 1 on the first layer, 2 on the second layer, 4 on the next layer, right? So what does that add up to? It's basically to the power of depth minus 1. You got that, right? To the amount of nodes.
Yeah, sure.
Yeah. So basically we start with the trunk tree and we get the leaves of the trunk tree. All the leaves, right? I mean, it's just there because we got the trunk. And then for every address that we have, we figure out based off of the leaves where though what subqueries we need, and we're calling these branch queries. So for example, let's imagine we have different leaves and we're going to use an alphabet. So we have leaf C and leaf F in the parent, right? And we're looking for address E. Well, you know that E is between C and F, right?
Mhm.
Makes sense. And that's kind of how addresses work. I mean, it just not one letter. It's just, it's big. So we basically say, well, I need the tree going to the right of C, and I need the tree going to the left of um, I forget the letter that we were using. I think E. Understood? So basically, we figure out what subtrees we need from the trunk. Are you following me?
Based on like your initial state with your initial gap limit.
Yeah, based off of the 100 original addresses that we were looking for.
Okay, yeah.
And then as new addresses pop up, we have a collection of all the leafs we've ever used, right?
Mm-hmm.
For every height. So every single time a new address pops in, we figure out, hey, did we query this subtree yet? And if not, okay, we add it to the subqueries that we need. Does that make
Okay.
sense?
Yeah, I think it does. I think next time we should add some diagrams. I think that will help
Oh,
people.
I know. I would have.
You were trying to get the demo working, and that would have been a lot more cool. But next week we'll
It
have,
would have been a
or
lot
in two
more
weeks
cool.
we'll have
That's what
both.
we were focusing on, and we're so close. It
But
just,
I think I get it.
yeah,
Okay, that's
yeah,
super cool.
and then every Merc branch actually, you just verify that the root of the Merc branch is actually equal to the parent hash.
Yeah.
And so
Can you,
then yeah.
All right, guys.
Wait,
We
wait,
okay,
have
wait, 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 wait.
one final question. Can you describe the scaling of the system? You talked about, this is based on 1 million addresses in the system leads to about 5 seconds. I just looked on core. We have about 4 million UTXOs, which is roughly synonymous to addresses. If you multiplied this by 4, the size of the system, would you be looking at a 20-second sync or like a 7-second sync?
Um, I would I'm gonna guess that it would actually be the same. It would actually not slow down even one bit. The reasoning for that actually has to do with how big, has to do with anonymity. I'm really sorry, Balash. This is gonna be five more minutes, and it just has to be talked about. So the we want to keep anonymity. And the problem with that is that let's imagine you get so you did the trunk, then you did a leaf, and underneath those leaves, because we're in a provable count sum tree, on every node, you know the count of the elements under the tree. You got that, Pasta? So for every
Yeah.
node, you know how many are below. So let's
Mhm.
say you have a leaf and there's 6 elements underneath it. And you know that the address you want is in those 6 elements underneath. If you were to just query those 6 elements, well, the node would be like, okay, you're one of these 6, or there's a high degree of probability, which is not good enough for your privacy. That does not meet the privacy requirements that we're looking for. So, or it could even be 1 out of 2, or it could, yeah, it could be 1 out of 4. It's Oh, sorry, one out of yeah, 1 out of 2, 1 out of 4. It's not very good. So what we do in this case, if we see that the tree is too small, we actually go up the tree and query for extra data downwards to always make sure that we have enough count to preserve anonymity. Does
Yeah,
that make
makes
sense?
Yeah.
And because 1 million nodes in the system is about 2 to the power of 20, um, it's not very divide, like our ideal height would be 888, right? So 2 to the power of 20 is 884. So we still have quite a lot to make it ideal in size. So we probably, could manage not 1 million ideally, but 8 million or something like that. Make sense?
Yeah. Huh. Very interesting. Okay, super cool. I look forward
Thank.
to seeing the diagrams in the demo.
Oh God. There is a dip
That's
on it that I started writing. Okay, so on top of this, I worked on a new thing. There was a feature request for minimum fees, or not minimum fees, but basically, um, Przemnik and his team needed to know for any state transition, how much do I need to use as credits in advance? So now this has been built and it will be released in 3.0. We also added strategy tests for platform addresses. And so we finished and merged in all the work for platform addresses. And what's left is basically JS SDK work, testing the system, and and yeah, I think I can't think of anything.
Sam,
So
real quick,
let's.
sorry to interrupt. Can you just repeat about the minimum fees again, just a little bit more?
Yeah, sure. So basically, the minimum fee validation existed in the crate drive ABCI, which was not made public in the SDK. So you couldn't actually ask what are the fees required for this state transition to execute on platform. But now you can. So before you send it to the network, you just verify that the user has enough fees, and then you send it a little slightly better.
Okay, cool. Thanks.
Okay. Oh, yes. So GroveDB, I had kind of had this slide last time, and I explained the system that we built for platform addresses. Under the hood, we're using a new type of tree. So last time I talked about state counted trees. Now it's state counted sum trees. So it's a state counted tree. So the count of every node is actually embedded into the proof of that node. And it's also a sum tree at the same time. But the sum is not embedded because I didn't see any use case for embedding the sum, and it just makes the system more complicated. So this has been built, it's been merged in, and we're using it. So it's a nice new type of tree in GroveDB that has uses. Okay, let's go on. Okay, a new thing that we have in GroveDB and Drive is the checkpointing system. So GroveDB can now make checkpoints against the state. And Drive will make, in 3.0, will make a checkpoint every 10 minutes. It will make up to 3 checkpoints. So how long does it take to make a checkpoint? It's less than 10 milliseconds. It is extremely fast, because how a checkpoint works is it copies over a file that is less than 64 megabytes. So your system, each checkpoint can only be up to 64 well, actually, like technically 64 megabytes and a little bit more, less than, it can't be more than 65 megabytes. So it will copy over a certain file and also have hard links to something called SST files in RocksDB. And this allows us to basically query to have a state of Grove, DB, and Drive at a previous time. And so, the system actually supports making query only I mean, they're not snapshots. Well, yeah, I guess they are snapshots. They're checkpoints, but they're snapshots of the state at a certain time, and then you can query that state and you can get back any data as that time. Now, when we're doing a long sync, for example, we're querying all our addresses. One negative thing is that you don't want the tree to change while you're doing all your queries. You want all the data to always be the same without modification. So you have to query against a checkpoint. Basically, the checkpoint will be in the last 30 minutes. So you'll take one like from 5 minutes ago. It actually automatically chooses it for you. And it tells you in the first query, hey, I'm using this checkpoint at this time 5 minutes ago. Then you sync all your addresses, and then you do a little check. A last part of the sync is basically syncing the last 5 minutes, which is, like one query to the system. It's very fast. So, yeah, we also introduced checkpoints. There was a actual issue in RocksDB around this feature, and I made my first pull request fixing an issue in the underlying RocksDB. There was, because we want our system to be extremely performant, using the default way of making a checkpoint would have led to a lot of unwanted files in the system. So something called an SST file. You don't want to make an SST file if the amount of data in that SST file is low. It's actually quite complicated. The point is, I made a pull request to RocksDB and Rust RocksDB. The one in Rust RocksDB has already been merged in, and 3 people reviewed it. So that's nice. I'm really happy that they were that they understood the issue and they merged it in really quickly. And yeah, so no other blockchain can have what we have because it didn't exist up till 2 days ago. That the feature in RocksDB just didn't exist. I mean, didn't work as the API suggested it did. So using very specific things. Okay, let's move on. Okay, mobile team. Thanks, guys.
Thank you.
All right. Thanks, guys. All right. So on the Android side, we essentially over our last sprint finished the dual username feature, which for those not familiar, will allow us to kind of not bypass, but at least have a temporary solution to use DashPay right away with a username if you chose to get a contested username. So you don't have to wait the full 2 weeks for the voting period. You can start using it right away under a kind of a similar non-contested username and ultimately transition one way or the other once the voting is done. So that was mostly done on that last sprint. On Dash Spend, CTX made some network changes that we had to adhere to. We already did that on iOS on a previous release, so this was just getting Android up to speed. There was also a small refresh token issue relating to the login that we had to deal with, and that and a new feature, transaction metadata, that we've been working on has been released and fully rolled out. So transaction metadata, more info will be coming, and probably maybe some other messaging or communication, and allowing you to save your your historical prices, transaction categories, gift card details, things like that on platform. So that will be preserved when you move from device to device or restore wallets. On iOS, a fairly light sprint. I'm really mostly the only one doing the iOS development for UI related work or new features. And I was away at conference, but we did get 851 release, which was the official Apple Store release for Piggy cards getting into the wallet. A couple other small bugs were fixed in there as well, but that's now fully out there and rolled out. And as already discussed, the mobile team did contribute a little bit to helping with the CoinJoin derivation path syncing on iOS. So that's that for iOS. I don't know, Sam, if you had more to add for iOS.
Uh, n no, I mean, the blocker is really on the Dash SPV right now. There's
This might be an
much
old
more.
slide from last. So
Oh, yeah, this is basically from 2 weeks ago that we just left. The iOS dev, while he started 2 weeks ago, he's been um he's been basically I mean he's only working like a few hours every week until 15th of January because he's leaving his other job, and then there's the holidays. He's Serbian, so the holidays for him are actually in January. So up till the 15th of January, he's, only very part-time, learning our system. And, once he starts, everything should be ready for him. And I will also probably go in and help him.
All right, thank you. Let's continue with the core team.
Cool.
Costa?
I've got 7 minutes. So here's the breakdown of who is running what. We did see a very nice chunk get upgraded this last period. We're up to right around 76, 77% on version 23. And so I would highly, highly advise at this point, anyone else that has not upgraded, that you really should. I've not been checking if we have been starting to see proof of service bans, but we are definitely in the range where it is very plausible that we will start seeing some proof of service bans for people who have not upgraded yet. Just kind of depends how lucky you get. So I would highly recommend that you update and don't risk it for no reason. So that's pretty much all there is to say there. Good progress this week. So, a number of things were worked on this last period. There are a couple of kind of longer things that didn't really get kind of wrapped up or PR'd yet, but so extended addresses is continuing. Kitty Whiskers was focusing on a couple of other things. I'm gonna talk with him probably later today and get an update there, but I'm hopeful that that can be kind of unblocked soon, and we could make some more progress there. Um, we do have some improvements to the kind of backup system for your wallets, for making automated backups so that, if you restart Dash Core a bunch of times or your wallet file gets corrupted, that there is a backup on disk that you can restore from. And this PR has been in review for a good little bit now, and I got some good feedback and was able to apply that. And so that should be able to get merged relatively soon. Constantine found an issue in basically the startup to sync, where we kind of went through all of the old blocks looking for, basically looking to see if there were like hard forks that we didn't understand. And then we would use that information to kind of indicate to the user, like, hey, you're probably running an outdated version. You should really update. But the way that that was implemented with our higher block count and also our higher number of hard forks, it was taking much longer in our system than in Bitcoin. And that's just because it was relatively poorly optimized. It would basically loop through each hard fork, and we were able to optimize that by kind of looking for all of them at once. And that has improved startup sync. So basically the time from launching, either dash core, or I mean dash D or dash QT, to the time that it's able to start like syncing headers and syncing blocks by about 5 to 8 seconds. So a nice little gain there. Um, Still working on some Wayland improvements. Didn't spend a ton of time there. That PR just kind of stagnated this last period, but it's not a huge issue. Just something I want to track and see if I can find some improvements. Um, but I think Constantine reviewed that this last period because he is running on a relatively recent Linux system that I believe is basically Wayland only, or at least has native Wayland running. Um, we also are making some improvements to our CI system. There were some caching improvements. There's migrating some jobs to ARM runners for improved performance. There's a couple of things like that. A couple of PRs got merged in for that this last period, actually, and then one is in review right now. There are some improvements that are being made always across the code base. Most recently, we're resolving some circular dependencies, specifically in some CoinJoin code. A lot of times you'll have stuff where, you know, something depends on networking and then networking depends on something. And it's ideal to kind of refactor that away and use interfaces and have a kind of more um, circular dependencies are generally not ideal, and if you can avoid them, it is valuable. And we have kind of a linter and a list of circular dependencies, and every once in a while we're able to spend time to resolve one of them, and CoinJoin was focused on recently. And then the thing that I worked on most, I talked with Sam and we um, had this idea for improving how we do the CF header sync. And I thought it made a good bit of sense. Well, not the way that he originally proposed it, but I saw his idea, and we were able to make some improvements to it and figure out how it would work nicely. And uh, right now, the idea is to use GroveDB to be able to basically query the the C filters, the compact filters to check, if a transaction is in a block. And doing this lets us skip a whole step where we currently have to download the CF headers chain, and we have to validate that. And in theory, we should, check that against multiple nodes. Right now, we just hope that someone isn't, spending a bunch of effort to be malicious, but we really should check that against multiple nodes. This improvement would allow us to simply download headers and then download the filters. And the filters would be in a GroveDB tree that would have its root in a Coinbase transaction. So it would allow us to just get that Coinbase transaction. We have all the headers. We know that this is like a trusted root. And then we would be able to just get filters and then validate that they're in the state using a very succinct proof. So this is there's some nice potential here. And so the last week or two maybe, I've been starting to work on being able to integrate GroveDB into Dash Core. I don't want to speak too much on this or make too many promises on this, but long term, also if we wanted to, bring more platform features into Dash Qt, having GroveDB around is something that we would definitely need. So this doesn't just have applications for filter sync. It may also have other applications in the future for, usernames and that kind of stuff, but no promises on that yet. But right now, I've got a FFI layer and a C++ wrapper around the FFI layer to be able to communicate with GroveDB from C++. And it'll just be compiled into Dash Core. Like it's not anything extra or anything that like any user will have to do. It's just a different database, right? Like it's just like right now we use LevelDB. It's just a different database, but it gives us this nice benefit of being able to have a proof and being able to send that proof out to people. And it's something that like is established in our ecosystem. So the mobile wallets already support it and that kind of thing. Um, so far, it is in progress. I've been spending a good chunk of time with this and working on this right now. Basically, the FFI side of things is relatively wrapped up. There might need to be some improvements there. Are a couple of spots that I have some concerns about, some like lifetime safety issues, but I think everything looks relatively good. And so right now, FFI and the C++ wrapper have been completed, and I'm starting to work on integrating it into our build system. Right now, there are some errors in CI that I'm working through, and hopefully in the next couple of days to week, I'll have it kind of properly building GroveDB when we build Dash Core, and then I can work on integrating it for kind of future use. This could also have, future very valuable or very interesting implications for all kinds of proofs, right? Like GroveDB is a very powerful structure. Um, it, right, like it's relatively simple in concept. We use Merkle trees all the time and that kind of thing. But if we want to implement new Merkle trees or stuff like that, like using GroveDB just reduces a lot of the overhead for features like that because we don't have to re-implement all of that. We don't have to, you know, redesign all of that. We can just kind of use GroveDB as a pre-built structure and just reuse it. But it's very extensible and able to be used for, pretty much all the applications that you might think of when needing to get proofs on stuff. Um, so that's pretty exciting. Anyway, backport progress always happening. I think V25 went up a couple of percents here, but nothing super crazy here to report. And we can move on to the next slide. And you can see the list of PRs merged in the last 2 weeks. Not as many as I would hope, but still a solid little chunk. And yeah, you can look through those, but we can move on. Questions?
Thank you very much. So we are running out of time, but we have a couple of questions. Let's take them. Do we have a timeline for Android migrating to the new Rust SPV / etc. system that iOS will be built on? Sam.
Well, this really is a question for me and Brian because I'm not sure of priorities here, Brian, in terms of does Hash have a lot of work for the month of, mid-January to mid-February, or could he focus on this?
More likely than not. I mean, iOS is going to be the priority one way or the other. If Hash can contribute, then we'll find a way to make that happen. But I think there's other factors other than just resources, as well as just kind of maybe the strategy on exactly how we do it, which we still need to talk through. But yeah,
Exactly. Also, like once it's done on iOS, we'll have a lot of understanding of the problems we faced, and it's probably going to make things a lot faster on Android. So it's probably better to do one than the next. Focus all efforts on iOS, then focus all efforts on Android.
All right.
If iOS proves to be, wow, this is amazing. This is working great.
Thank you.
As we know it will.
Next question. How easily, yeah, sorry.
Yeah, so that just for an answer there, Android will be after iOS, right after. So how long would it take to integrate? It wouldn't take longer. I mean, probably would not take longer than to integrate iOS. So whatever time it takes, right now we have that at 1 month for iOS. It would not take much more than that for Android. There's no reason why Android would take. Oh, there is actually. because there's we didn't write the Kotlin SDK yet. So Kotlin SDK would take 3 weeks, 3 weeks to a month. And so, yeah, we're looking at about 2 months.
Thank you. Next question. How easily can websites be built on Evo today? What steps can someone take to build a blog, for example, and store everything on Evo?
Well, you create a blog, you use our JavaScript SDK, and you create a contract with like just a blog post inside, right? And various other metadata that you might want. I don't know, like, maybe a blog post has likes, or you could have
Author, date.
class. Yeah, like there's like the metadata involved, and you figure out your business logic. You create a contract for it. You publish the contract to platform. Then you use that contract in the SDK, and you write documents to platform. And then you the website itself, to show the documents, will do queries for those documents. That's basically the way you would build it out.
So Sam, those are the steps, right? But I'm not sure. Maybe the question is, how
Oh,
long is it until we're able to do all of those steps, or are we ready now?
you can do it now. I mean,
Okay.
I mean, I showed it with Yapper already that it was possible. That was like what, 5 months ago. Like, yeah, Yapper was in a star state because I only spent 2 weeks building it, right? Like, but without even knowing any development, um, oh, I did not for Yapper. I literally only used AI, and I was able to do it. So yeah, with the JS SDK, you could do it right now. There's nothing stopping you.
Cool.
I would say though that the improvements in 3.0 that are going to be released um next week would make things like not sorry, not next week, like whenever 3.0 comes out, so probably in 2 weeks. Sometime in early January when we're done testing, and uh that might improve things. You could once we have a release candidate, you could probably use the release candidate instead of um the version that will be um you probably don't have to wait for 3.00, and that will just give you a better experience. However, no, you don't need to. Like, the current system does work. It's just not as user friendly as
Thank
the new
you.
one. Yeah.
Next question. What are the descriptor wallets, and how does one use one?
What are
Yeah.
descriptor?
So
Oh.
this is a core question. So descriptor wallets are basically just a kind of technical implementation detail. They're a new wallet type and kind of standard. Bitcoin implemented them a while ago. Um, they like are a standard that comes from Bitcoin. Basically, the idea is that instead of just storing um instead of just storing the like private key and address, like the idea is to um kind of describe how to generate what you need. And so like in an HD wallet, like that would be more like holding the path, right? Um, so it's mostly just like a kind of technical detail, but the implementation of it has allowed us to um, basically hold multiple HD paths at the same time in the same wallet, right? Previously, we only could really support one path, which is like fine for core. But really, when using HD, like it's nice to be able to segment stuff in different paths. And like the mobile wallet uses a special path for coin join, and they use a special path for, change, and they use a special path for other things. Um, Historically, core didn't really do that. It just derived and then it kept metadata about that. But that's not ideal because like if you just reload your wallet um from a like from HD, like you kind of lose some of that metadata. Like it's nice to have this segmentation. So mostly descriptor wallets are just a like technical detail in a new wallet type that allows us to do that. That comes from Bitcoin, right? Our original HD wallet implementation actually predates Bitcoin having HD wallet support. When they implemented HD wallet support, they did it via descriptor wallets, and we're now bringing that into our project to kind of unify the implementations and support multiple paths and those kind of things. Um, they are now considered like non-experimental in Dash Core. They've been non-experimental in Bitcoin Core for quite a while. Um, but so when you create a new wallet, there's an option that says use descriptor wallets. Um, from a user perspective, doesn't really change a whole heck of a lot. Like it just doesn't. Um, yeah, that's pretty much all I got for you. It's a useful thing for having the separate paths. If you want to, restore a wallet from like a mobile wallet and they use multiple derivation paths, like you would want to use descriptor wallets, right? Like if you want to use Dash Core with your wallet and you want to do like custom derivations on different paths, I think with descriptor wallets you can like generate at a specific path. I'm not positive about that, but I think that's exposed to like the RPC. So there might be use cases there where like you would derive a specific path in your seed for like receiving funds from specific users or stuff like that, right? So there are useful applications for it, but ultimately it's not that user focused. It's more of a technical implementation detail.
Thank you very much. Next question is it possible to get instant send latency down under 1 second, theoretically, with optimizations?
Well, so um so on mainnet, right, it's a geographically distributed network. Primarily it's semi-centralized in Europe, right? Like Europe is the biggest concentration of masternodes, but there's quite a few in North America as well. There are a number of them in Asia, very few in Africa or South America. So mostly Europe, then North America, then Asia. If you look at like the round trip latency times from say North America to Asia, um, you're looking at around 300 milliseconds, right, for a round trip latency. The way that instance send works is that it does and that's just like the lowest level, like the best case, like that just is the physics to get data from, Southeast Asia to North America, right? Like there's nothing you can really do about it unless maybe you like somehow convince your data center to route some of your traffic over Starlink or something for extra low latency, but that's not something that I think anyone does and
No,
probably would be very
Pasta,
expensive.
Pasta, you need to go back in time first, find Einstein, tell him that he needs to stop um figuring out the, relativity. He needs to invent warp drives to make faster than light uh information. There you go.
Yeah. Um, so the best case, if everything signing wise and everything like that happens instantly, assuming round trip latency on the network of around like 200 to 300 milliseconds is like half a second to close to, 3/4 of a second, because the way that instance send works is it does multiple rounds, right? Like the first round establishes that these inputs are locked to this transaction ID. And then once all of the inputs are locked, then you get the final, you do the signing for the instance end. So because of that, you have multiple rounds. That really puts your like low level, assuming that like all compute is happening instantly and like everything like that. It puts you really close to a second. So anything below a second is like practically not possible on a decentralized network. Like it just like latency wise, it just isn't really a thing. Um, I mean, right now, right, it's sub 2 second. Our average is right around 1.8 seconds. I think some of the improvements will see it go down closer to 1.5. Honestly, I think you kind of have diminishing returns at this point. Like, I don't think there's a huge user benefit case going from 1.5 to 1 seconds. There's some argument that it, could improve throughput because that's less data that we have to keep track of. If we can, have better latency, that's less stuff to kind of keep track of. But I think, and it like there are some cases where we can try to like optimize for certain stuff, because like right now there's some cases where we kind of bundle things together and we do it like every 100 milliseconds, right? Like there are some trade-offs that you could make that maybe would improve latency but might actually reduce throughput. So you don't really want to do that because honestly, 2 seconds or 1.5 seconds is already really good, right? Like, so you don't want to do anything that might degrade throughput. So you want to be able to do these like batching and things like that. But when you do batching, right, like that inherently means you're like waiting to batch it with other things. Um, so the gist is under 1 second, I think very unlikely. I don't see how that would work unless everything becomes very centralized in Europe. If everything becomes very centralized in Europe, right, like under a second is probably possible. But do we want
Just
that? Probably not.
yeah, just to reiterate, right? Like if you're in New York, and if one node is in New York and the other node is in Sydney, the speed of light going around to from one place to another is 60 milliseconds. That's the speed of light. There cannot be any information traveling. I mean, the only way information could travel faster than that is actually going through the Earth. Obviously, we don't. Um, there are no mole people yet to make those tunnels. But yeah, so there's like a hard coded limit in our universe to these problems. Like when we are using a decentralized network, obviously with a lot of effort, we could probably reduce, as Pasta said, we could probably reduce that number because 60 milliseconds for one connection, and we're making a lot of connections, and then sometimes we have to do an extra relay. So if you think about it, at most there can be a certain amount of hops. If we did the hops on the network based off of location, so you would hop to places, to IP addresses that are closer to you, these are things that could shave off milliseconds. Is it worth it? No. The opportunity cost is just the amount of work for almost no difference. It's just not there. Maybe when Dash reaches $100 billion in market cap and we have so much money in the development of Dash that we don't know what to do with it. Yes, okay, maybe, but right now we're not there. There's a lot of stuff that we could build that would provide more value.
Yeah, and right, like the speed of light, right, like is the ultimate kind of bottleneck. But even before you get to that point, right, like the backhaul networks aren't hyper low latency either, right? Like just doing some quick ping testing from Chicago to in Singapore, and Singapore actually does have quite a few. Singapore has 500 masternodes, believe it or not, 494. I just looked at map.thepasta.org, which is kind of cool to visualize this. But going from Chicago to Singapore is 200 milliseconds, right? Um, so you have you have two of those for the 2 rounds. Like that's really like there's a lot of overhead to get down to that. There's a lot that you would have to be able to trim, but you know, you're looking at 200 to 300 milliseconds. But also, right, like it is the worst case connections that are going to limit the latency of instant send, right? So you really do need to be looking at like the, you know, Chicago or New York to Singapore type situations, right? Because ultimately that's what is going to be limiting instant send most of the time is
Yeah,
those worst connections.
thank
I,
you.
I would like to say though that like it is kind of magic though that we're sending these messages at near speed the speed of light. Yeah, what when you think about like why it's 200 milliseconds and not 60 milliseconds, it's because on the it goes through a few hops from one data center to another. They're fiber optic cables. The fiber optic cables themselves send it at the speed of light, right? Fiber
I
optic.
think it's slightly slower because it's the speed of light through glass, so you got to add a couple of milliseconds.
All right. Thank you very much for this thorough explanation.
Oh,
Next,
yeah, you're right. Oh my God. Pasta's been right too much recently.
So like there are some things to improve. Getting it under a second, it'll be a hard stretch. There might be some more improvements to get it down closer to a second, but it'll be hard and maybe not worth it.
all right. Thank you. So, last question. How can we enable trustless staking for masternode/evo nodes at protocol level without complex multisig setups? We have 7 minutes to answer that. That's the cap.
Um, conceptually, it it's been thought through, and there are ways that conceptually it could be done. Um, it's I would
It's
say
one of
it's
those things that I think as well, like if we're 100% sure that it's needed at the protocol level, we'll do it. But right now, I mean, it's a lot of effort, right?
yeah, it is quite a bit of effort. It would be a hard fork. It's not like a trivial thing to do by any means. It would need a lot of testing. There is like potential for issues whenever you make a big breaking change like that. And so it is a question of is there there are like complications and like nuance to what do you do and what trade-offs do you like. It's kind of nice to be able to like offload that to like a third party to make decisions. So it's not the protocol saying that you have to lock it up for 90 days or whatever, right? Like it's nice to be able to just kind of give primitives and let kind of people decide. So like already, right? Like the systems are in place to be able to do all of this. It's just a little complicated. Um, and like you could streamline some of these things, but it's a good chunk of effort and whether or not it's worth it, um, right? Because it's really just making it easier to do these things, right? Like these things are possible. It's just how do you make it like easy? But you can't necessarily just make it such a thing where a user says, "Hey, I'd like to stake 50 Dash. Please do it for me," right? Because well, who are they doing it with, right? Like it's it's kind of an important thing to right trust that the person running the masternode is doing the right thing and that they're actually running the right software and that they're participating in the network like right it's not really something where you can just have a open market type thing and say, here's my 50 dash, someone please take it and put it in a node, right? Like that's not
You
really the type
could,
of
but
system that you would
you
want.
would need like, it's not simple. You would need like a review system, you know, like you would need, oh, this guy has like 15 reviews, he's hosting, he has an uptime of this amount. It's a whole ecosystem that needs to be built in a decentralized way. It's possible though, right? It's just not uh probably the most high value thing to do right now.
Yeah,
You
All
would
right.
agree.
I would because it is like possible. And I don't think like it would be nice to just have a one-click button that says, I would like to, stake trustlessly with this provider, and it just happens. Um, but I don't know if the added complication is worth that level of simplicity, or if it's fine to say, I'm going to press this button once, and then a week later, okay, we found enough matches. I'm going to press another button, right? Like, is pressing that second button really that big of a deal? Like, I,
Also, like, it's not our one of the reasons why we reward um 4,000 like for when you put 4,000 dash away in Evo node or 1,000 dash away in a master node. I mean, you're serving the network. So you're serving the network and by providing the service of the Evo node. And when you are doing it like in a shared way, you're also providing that service. When when you have like, a small amount or of dash and you're just like pressing a button and you're just not, I mean, you're not really providing any service to the network. I guess the capital service of the 5 dash might be of some service, but the real service is the person holding the Evo, the master node or the Evo node. Um, and like, because if you take like too many small inputs, uh, what and those inputs break the master node and the Evo node very often, I would argue that it's not a real benefit to the network. Like our network is very stable right now as well. And I also really like the service that CrowdNode provides. They really like have done an amazing job, and I hope everything works out very well for them.
I think that's maybe the premise for the question, because of there's been there's quite some challenges regulation wise in EU, and there's a lot of risk of crowd node existing in at least 2007. I don't know about, I'm not sure about 2006.
But if they don't, is the problem for them holding funds or running the masternodes?
I don't know all the fine details, but I do know that the EU regulations are a real challenge for them.
I mean, if the problem is holding funds, which I'm guessing it is, not running the software, so they could make their system a little bit more trustless. Their trustless masternodes could just have a slight it would take them a little bit of development work, but you would have to sign a multi-sig transaction instead, and I'm sure it's doable for them. I mean, I don't want to sorry, I shouldn't say what is doable for them, but
Yeah,
if
I'm
they're
not saying what is and is not doable. I'm just saying
yeah,
those are the challenges, and I suspect that's why the
yeah,
question was asked.
yeah.
yeah, I can reassure that like it is very possible to do a trustless masternode in a completely trustless or a completely non-custodial way. One of the benefits right now with the way that CrowdNode does it, and I think one of the like reasons why that they do it, is that it can take, a couple of weeks to find all the people that will, join together into a masternode, right? And so right now on CrowdNode, right, those funds are still, kind of accruing interest, like they're able to be used, they're, getting rewards. But, if you need to do everything completely non-custodial, You just have to take that time, right? Like it's going to take time to find people, and those Dash are just kind of going to be sitting there in that time.
Thank you very much. We ran out of time, sadly. Thanks for the questions, for the feedbacks, and thank you, the team. We are going to give you an update in 2 weeks, I believe. So see you in 2 weeks. Thank you very much.